Hi guys, I'm Dr. Sirisha Devi, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to look into searching techniques. In my previous session, I have given you an introduction of what a data structure is, what are its basic operations, and what an algorithm is. Right? So, while we were learning about the basic operations of a data structure, we have seen that searching operation plays a vital role, right? So in this session, we are going to learn about searching techniques, right? Now, what do you mean by searching? Everyone knows it. You're searching for something, searching for a record, coming to your data structures concept, searching a record or a data or a key element in a lot, in the whole structure is nothing but searching. In this session, we are going to learn about two important searching techniques. One is linear searching technique and the other is binary searching technique, right? So what do you mean by linear search technique? It is a very simple, straightforward searching technique in which we are going to search the data sequentially, one after the other. Say example, n number of elements are there, then one after if I ask you, if I give you a key and says with some value x, search for it. So compare it with the first element. If they're not equal, compare it with the second element. If they're not equal, compare with the third element, and you are going to do the same till the end. Till the end of the whole list is nothing but your linear search. So, and its time complexity, how much amount of time it takes, how many units of time it takes. Yes, the number of units is, for example, the element which you are searching for is the last element of your list. Then how many comparisons you are going to do? N number of comparisons. If nth term is the element which you are searching for. So, the time complexity will be order of n, big of n. Right? So this is a straight algorithm for your linear search. You know that when we store data in contiguous memory locations, system internally gives them their index values starting from 0, so on to 0, 1, 2, 3, so on to n minus 1, n minus 1 if there are n number of elements in your list. Right? So first of all, point out to the first element, compare it with your key element. If there is a match, then it is a hit. Revert the index, display the index or the position and say that the element is found in so-and-so position. If not, increment the cursor and check whether the second element is equal to the element you are searching for or not. I'll show it. I'll explain you this with an example. Yes. This is the list which I'm going to take right now. So the list consists of 5 elements, randomly placed, 21, 54, 36, 18, 29. And the key element which I'm going to search for is 18. Okay? Right. So initially I'm taking an I value. I is nothing but a pointer, just to point out. Now initially I is going to point to the 0th index value, which is 21. Compare it with your key element. Is 21 equal to key or not? No, it is not equal to key. Then increment the I value. Now your I is pointing to 36. Right? So next. Now, is 36 equal to your key? Your key value is 18. No, it is not equal. 36 is not equal to 18. So increment the I value. Now, is 54 equal to 18? No. Increment the I value. 18. Is 18 equal to key? Yeah, there is a hit. So just say that at an index value I, the element is found, or you can also say that at position I plus 1. At I plus 1, because the index values start from 0. At position I plus 1, the required key is been found. right? I hope it was clear. Simply searching one after the, first of all, start with an element at the 0th index, compare it with the key element. Do it unless you reach the end of the list. Then what will be the worst case of linear search? If the element is not there in the list. Even if the nth element is not equal to key, then we call it as the worst case, right? So, a contrary to that is binary search. Binary search. Always, guys, always pose a question to yourself. When there are n number of ways, okay, say here 2 ways are there to search. Why you are going for the second one? First one is quite easy. Compare with one element, one after the other element, reach the end of the list. It's fair game. Then why we are learning binary search? There is a huge drawback only when, just like your commercial mobile phones, right? Whenever a new version comes, the company promotes that the earlier version was not having this feature, so we have upgraded it, right? Similarly, linear searching is having its drawback. Say, the basic drawback is linear search works very good, very, very good if the list is small in nature. It means if there are a handful of elements. What if the linear data is huge in nature, huge data set? Then if you are finding you are trying to search for an element in that huge list, it will take huge amount of time. Don't you think that time complexity is order of n? That itself is a drawback, right? What if the element is the last element? If the element is the last element, unnecessarily you are compared with n-1 element. Can't you reduce this effort? Yes, you can reduce this effort if you go for binary search. Yes, binary search brings down the hurdle to half of that, right? And it relies on divide and conquer. Divide and conquer means at every step it is going to break the current list into half, 2 pieces. That's why its time complexity is order of log n. Let's see the algorithm for binary search. It's a very simple one. Don't compare the element you are searching for with the first element or the last element. Compare it with the middle element. Is the only funda of binary search. I'll explain you with an example. Don't worry. So if there are n elements, say there are n elements in your list, break that into 2 halves, right? So left half, right half, you will have some element in the middle, right? Compare your key with the middle element. If you compare that with your key element, then you will get an idea where your element lies. Guys, one major important point to remember, the prerequisite. While learning for linear, I use the word random. The elements are scattered randomly, right? But the prerequisite for binary search is the list which you are going to take must be sorted in nature. Sorted, either ascending or descending. Either way is okay, but it must be sorted in nature. Our task is to search for an element, right? So for that, if it is existing or not is the only point, right? So then sort the element, sort the whole list, then perform this operation, right? So come back to the algorithm. Compare with the middle element. If your middle element is greater than the key element you are searching for, obviously your element is the element which you are searching for is on the left hand side. If your middle element is less than the key element, right? The key element which you are searching for, obviously in the other side, right? So please keep that in mind. It's all the game of less than, greater than. If it is equal to, then it is a hit. The mid element is the element which you are searching for. I'll explain you with this example. Just have a look. I have taken the same old list which I have taken for linear. 21, 54, 36, 18, 29. And I'm searching for 36 now. Not 18. 36 now. What is the prerequisite? Sort it. I have sorted it. 18, 21, 29, 36 and 54. I'm taking 3 pointers. Left to represent the leftmost element L, to represent the rightmost element R, and to point the middle element M I have taken. So as there are 5 elements, the middle element will be at index 2, right? So now I'm going to compare. Is the middle element is 29. Is it less than key or greater than key? My key is 36, right? So as my key is 36, obviously 29 is less. Then on which side my element, the element which I'm searching for, is going to lie? Obviously on the right hand side. Then I'm going to forget about this list. I'm concerned only with this list now, right? Because my my comparison statement tells that it lies on the right hand side. So I have repositioned my left to M plus 1. Now it is going to take a new step. L is being repositioned. L is repositioned and again calculate the M value. Now M is going to point to 36. Now is the middle element equal to the key or not? Yeah, it is a hit and it returns the index value. This is how you are going to implement binary search. Always at each and every level, you are going to break the list into 2 halves. Either right pointer is going to move or the left pointer is going to move, thereby reducing the current list into half at each and every step. Right? I hope you understood linear and binary search. Guys, my advice for you guys will be take random elements and try to implement the same. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.